Hello, everybody. My name is Jay, and I am here to introduce to you calculus. Some say it is the hardest math. Honestly, for me, it could be harder. There is a lot to learn for the curriculum, for the AP exam. I am here simply to teach you base level calculus, what you'll need to know to succeed on the AP Calculus AB and BC exams. So the first concept we're going to talk about is instantaneous versus average rate of change. Now, let's start by talking about average rate of change. Many of you may know this as slope, and it is the slope of a linear line. For example, let's take this point and this point. This point, let's say it's 2, 2. Take this point, let's say it's negative 1. Negative 1. The way we would traditionally find the average rate of change, or the slope, is by doing y2 minus y1 over x2 minus x1. And that would be equal to 2 minus 1 over 2 minus 1, which would eventually just be equal to 1. But when we're talking about a quadratic function, we wouldn't call this the slope, right? Because this point here, what is it? 0, negative 1. And this point, that is going to be 2, 2. This is a very rough drawing, by the way. I'll just fix that really quick. Let's draw some new points. Let's say 0, 0, 2, 2. Regardless, in a quadratic, the y2 minus y1 over x2 minus x1 graphs the average rate of change. It represents the average rate of change, but it does not represent the slope, obviously. And yeah, this is obviously very easy. I'll just do it out. 2 minus 0 over 2 minus 0. Again, this is just going to be a 1. So we know that it's the average rate of change is going to be 1 over this interval. But what we don't know is, how do we find a slope at a point? And this is going to be the concept that I will introduce to you. Your first, probably real calculus concept that you're hearing of. Just give me a second, and here we go. Take this point 0, 0, for instance. We know that the average rate of change of this point 0, 0 and this point 2, 2 is going to be 1. We did this by doing y2 minus y1 over x2 minus x1. But what if we want to make it smaller? We'll take this point. What is that? 1.5, for example. Let's just say that's 1.5. Suddenly, our slope, our average rate of change, is going to change, because you're graphing this at first, this line, but now you're going to graph this line, and you can just keep making it more and more and more accurate until you're eventually going to find that you can make it as accurate as the point itself. So you can eventually make it infinitesimally small number at 2, 2, Like, for example, 1.999 repeating, 1.999 repeating, if that is a point. And you can use that in order to find the infinitesimally small number of 2, the infinitesimally small average rate of change of 2, and that is what we call the instantaneous rate of change, because you're getting so small, so microscopically small, to being the actual instantaneous rate of change, the actual slope at that point, that we have to call it instantaneous rate of change at that point. We have to call it the slope at that point, or instantaneous rate of change. All right, that is your first calculus concept. We are going to move on to limits now. Limits you might have done before. I know they were in my pre-calculus course. Some of you might not even have a pre-calculus course. So I will introduce you to basic limits. Limits are where a graph approaches at a specific point. For example, take this point 3, 3. As the graph of f of x, let's call this function f of x. As the graph of this function f of x approaches 3, the function is going to go to 3. So as f of x approaches 3, it will be going to 3, right? So we call this a limit. So the limit as x approaches 3 of f of x is equal to 3. I'll break this all down for you. For starters, the limit of, you need to write this limit. This signifies that it is a limit statement. This signifies where it is approaching. This signifies what the function actually is. So, like, what we're actually using to approach the particular number, and what number it ends up approaching. Right? So what we're going to do is we're going to look at it a different way. We're going to look at it phonetically. We're going to say it out, and then I'm going to write it down. So the limit as, so this is the limit as x approaches 3 of f of x is equal to 3. And you might be asking yourself, well, how is the limit as f of x approaches 3 different from f of 3? In this case, it's not. But in other cases that we will see in the next video, it definitely will be. So it is very important to realize that this, for now, is equal to f of 3, but it won't always be equal to f of 3. And, so, yeah, this is the basic bread and butter that you're going to need to know. Bread and butter, as I call it. It is the basics of calculus. Your instantaneous rate of change, and your limits. Your limits are incredibly important for this course. I'm telling you, it is probably the most important thing for this course. Limits are your fundamentals. They are one of your fundamentals, and they are one of the things you need to know. really, really, really well. All right. I think that's going to be all for today. So, I'll do one practice question with you. Let's take this point. Let's take this function, right? This is going to be y is equal to x squared. All right. Now I want you to find the limit. Actually, we'll call it a different name. We'll call it g of x. The limit as x approaches 2 of g of x. What is that going to be equal to? I'll give you 2 minutes to do it. Well, not 2 minutes. That's a bit long. We'll give you, we'll let you pause the video. Give you like a second or two to do it. So obviously in this scenario, the limit as x approaches, so take a pause for a second. Replay the video as soon as you have the answer. In this case, the limit as x approaches 2 of g of x will be equal to g of 2. It won't always be equal to g of 2, but in this case, since g of 2 isn't in a separate point, okay, we'll just say for now, let's define the standard as it will usually be this. The limit as g of x, as x approaches 2 of g of x is going to be equal to g of 2, which will be 4. We're going to see new scenarios tomorrow where the limit as x approaches a certain number, we'll call it c, of f of x will not be equal to f of c. So we're going to check that out tomorrow.